We are out at the DMI launch event for the DP30 and the DS30 hydrogen fuel cell powered drone. We've been out here for a few days. Essentially, we've got a drone here that is a SUAS, so under 55-pound drone that can fly for about 2 hours on compressed hydrogen gas, totally clean energy. We're building out an entire network to be able to refuel hydrogen and swap out tanks, so it's just a seamless, easy experience. And what we're seeing is basically 6 to 10x productivity over a drone that flies for 20 to 30 minutes. We're even seeing a lot of use cases where we're able to fly missions that just weren't possible before, where you might have to fly 20 or 30 minutes to an asset, then inspect it, and be able to fly 20 to 30 minutes home. Really, really excited to see the different applications that people are working on. It's quiet, it's efficient. The entire thing was designed from the ground up specifically for this kind of hydrogen power. The response has been great over the last few days. I'm really excited to see these things going out into the field next month and see what kind of applications we can do when we're flying for 2 hours.
Islands, because we are multiple islands. We're collecting samples from the other islands, but we're having to send them back. Right now we're sending them on a seaplane. You know, following the storms, the airports are closed, there's no flights. We are doing it by boat. People just stop going to the doctor for some things, knowing they're not going to get a result back.
We're going to launch from the island of St. Croix here, go all the way to St. Thomas, which is about 40 miles away, and we need to be able to keep the drone in line of sight, so we're just going to follow it with a boat that we've chartered.
I think the drone that we're actually using for this test is probably the most exciting part about all this. It's the Doosan DS30 aircraft with the DP30 power pack on it. It's actually powered by hydrogen fuel cell technology, and so we're talking about 2-hour flight times instead of the typical 25 to 35-minute flight times.
Landed about 7 minutes ago. Oh! Yes! Nice job. They landed. It took about an hour and 38 minutes from takeoff to touchdown. We just got confirmation from the USVI Police Department, who is helping us do the landing, that they landed about 7 minutes ago. So.
We want to show that drones can be used to help people. They can be used to supply medicines, to be used for business, commerce, used for disaster. In terms of disasters and flooding, how do you mitigate such issues? So this is why we want to spread the word for them to understand how beneficial drones are.
두산모빌리티이노베이션 is specialized for hydrogen fuel cell technology, which can enable long endurance flight with the drones. With hydrogen fuel cell technology, we can fly longer hours, up to more than 2 hours with multi-copter drones. And I think this energy and this technology will really benefit Africa, because I believe Africa will need long endurance, not just for delivery, but also for other various applications. Some people misunderstand that this is future technology, but this is actually in place, and this is available, so you can use this technology for the application that you are pursuing now.
Korean team that has brought over a hydrogen fuel cell powered unmanned aerial system. It's incredible, unique of its own right. We've been putting it through its paces, testing in fog, in nighttime operations, in a tethered capacity, and delivering high definition video and thermal imagery.
I'm reproducing the stream. Okay. So.
Many drones are currently used in various industries, and the use of drones will continue to be expanded in environments that are difficult for humans to perform. At Dusan Mobility Innovation, we provide 2 hours of flight time and the exponential opportunity that additional flight time brings to industrial drone users. The DP-30 is the world's first mass-produced hydrogen fuel cell system for drones, which has about 4 times longer flight time than battery drones. And the LTE-based monitoring system allows the control center to check the power pack status and maintain optimal conditions. Rear LEDs provide warning indications based on power pack status and hydrogen level. The hybrid batteries placed inside the power pack ensure a landing time of the aircraft in an emergency situation and enable a stable flight at a blast of wind compared to existing industrial drones. The DS-30 has a water drop shape that minimizes drag and is optimized for a power pack. The height of propellers and power pack is the same for maximum flight efficiency, and it is made of octocopter type to enable a stable flight. It is also possible to return home automatically after completing missions in BVLOS using LTE communication network. What can be done if Dusan Mobility Innovation's exceptional flight time drones are used throughout the industry? Help to save lives of our neighbors and humanity by searching missing persons, monitoring high crime areas, and delivering emergency supplies to the disaster sites. Possible to utilize finite energy efficiently by inspecting offshore wind power plants and transmission lines that are difficult to access, and analyzing the status of large solar power plants. In addition, maximize the productivity of industrial sites by creating three-dimensional modeling of large-scale construction and mining sites with just one flight.